Welcome to solverfy.
All right, so in this question, we're asked to produce the alcohols that you would oxidize to produce these things. And I'm going to use a retrosynthetic arrow, which means I'm essentially going to draw a kind of big arrow like that. And that's to represent that I have the reactants, or I'm sorry, I have the product, and now I'm going to show the reactant. Okay, so starting with A, this is very strange because we have an aldehyde, right? So the only thing that could have produced this is this alcohol. All right. So now what we kind of need to be careful of is we need to have a weak oxidizer. So I'm just going to add plus weak oxidizer. Because if I have too strong of an oxidizer, I'm not going to end up with an aldehyde. I'm going to end up with a carboxylic acid instead. All right. So going on to the second one, using the fact that I have that carboxy right there, obviously that's going to be the alcohol that we need to get there. Now, since this is a secondary alcohol, it really doesn't matter whether or not we use a strong or a weak oxidizing agent, simply because of the fact that it's not going to change once it reaches this ketone. All right, last one, going back. Now this one, pretty similarly, we're going to have to have an alcohol that looks vaguely like this, right? And that makes sure we keep all of the carbons intact and that the alcohol will be added at the site of the oxygen. Or I'm sorry, that the carboxylic acid will be added at the site of the alcohol. But now, instead of using a weak oxidizer, we need to use a strong oxidizer. And the reason is that we don't want to stop at just the ketone. We want the whole carboxylic acid. So we need a much stronger oxidizing agent to guarantee that we're going to get to that state.